So at this point, we've done a lot with quadratic equations. We have solved them multiple ways: factoring, taking the square root, completing the square, quadratic formula. No matter how you solve, you should get to the right answer, assuming you solve correctly. However, at this point, I've been really telling you, hey, I want you to solve it this way. I want you to solve it that way. And there will start to be patterns where some ways are easier to solve than others based on the type of quadratic you've been given. So that's what we're going to talk about today, is trying to figure out the best method to solve something, and then also using the discriminant, which we'll talk about, using that quadratic to even decide how many answers we should be looking for. So the techniques that we've looked at is factoring. You want to use factoring when it factors easily. This is key. If I come up to something and I can't quickly factor it, I'm going to jump to a different way to solve. And so if you can look at it and you're like, oh, this is going to be really easy to factor, when I have it equal to 0, obviously, or if I just have two terms and I just need to factor out one, these are times when you're going to solve by factoring. And they give the example. If you have an x squared and an x and this 42, you hopefully can see that 7 and 6 are your factors, and you can very quickly factor it and solve. Like, I wouldn't use the quadratic formula here because I can clearly factor that 42 really fast. And so the example that they've given is perfect for a solving by factoring. Taking the square root. So taking the root is when you do not have a middle term, or if you've been given like a binomial already factored like they gave you, or a perfect square. So if I just had like something squared and adding or subtracting something and I didn't have that bx, I would probably just take the square root here. I would get that x squared by itself and take the square root. Or if I can see that I have a perfect square, like the one that they've given me, then I'm just going to take the root of both sides and solve that. I'm not going to FOIL that out and then try to get quadratic formula. That doesn't seem practical. If neither of those work, I go straight to quadratic formula. So if I don't quickly factor it, or if I don't have an x squared that I can get by itself, I'm going to jump to quadratic formula. Because quadratic formula always works. Unless you just mess something up typing it in, you're going to hopefully get the right answer. All right? Notice completing the square says directed to do so. I did teach you completing the square, but that is not the most practical way to solve these. The reason you need to know completing the square is there are times when you are inside of a root and you have to force a perfect square to get out of the root. So this is the only method to do that for solving other types of problems in algebra, pre-cal, and calculus. But if I'm just solving a quadratic, I can promise you I never go directly to completing the square, right? I'm going to try the other methods. And typically, I'm never going to do completing the square unless I'm specifically trying to get something out of a root, and I need that to do so. So if we look at example 1 here, as I'm looking at these, I am going to say, what would be the easiest method to solve these? If I look at A, what's the easiest way to solve A? Right? So if I want to solve A, I'm like, well, I just about have x squared by itself. I'm going to go ahead and divide both sides by that 3. All right? Because I get x squared equals 18 here. While 18 does not have a perfect root, I can certainly simplify that root easy enough. Take the 3 out, leave the 2 in, and remember, I took a root with a variable positive and negative. So even without being directed, that's the easiest method to solve this, right? That's the easiest method. Look at B. Easiest method to solve B. My first step in factoring is to take out the common factor. What is the common factor here? I have 4x. I'm left with x minus 3. Very simple factoring. Set that equal to 0. Set that equal to 0. And then solve. So x is going to equal 0 or x is going to equal 3. Very easy to solve that one by factoring. Look at the last one. 3x squared minus 4x plus 5. All right, so I could potentially look and see if I can factor it. 3 times 5 is 15. I'm just going to have to find factors of 15 which actually don't exist to get negative 4. So even if you went your method and tried to factor, this guy's not factorable. Technically, you could complete the square. It would require fractions to do so. That would be a pain. You cannot get x squared by itself. What do you think I'm going to do here? Quadratic formula. So I'm going to say negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so as I do this here, even if you get, in this case, negative in your root, that's fine because we know we can pull that out with an I. The thing I want you to pay attention to, just like we talked about over the last few days, is that when you are doing these, make sure you are simplifying correctly. When I simplify this, remember I can only simplify my outsides. So it has to come out of the 4, the 2, and the 6 to reduce it. What comes out of 4, 2, and 6? A 2. So I can reduce every one of these by 2. The 4 divided by 2, the 2 divided by 2, and the 6 divided by 2. Cannot simplify that 11, even if it was something that was even. Corrected. So in this case, it's telling me to solve by factoring, by completing the square, by using the quadratic formula. Just looking at that, granted it's not in standard form. Which two of those look like you would not want to be sitting in a test for me and do that particular way? I would actually probably agree with you, but yeah. So he's saying B and C. So 4x squared minus 28x. I'm going to go ahead and put this in standard form, right? Equals 0. I definitely wouldn't want to do this guy. Why do you think I wouldn't want to do him? That's going to be horrible. You have to actually get rid of that 4. You have to divide everything by 4 first. And then you're going to have fractions, which is actually hideous to do, right? Using the quadratic formula is not bad. You're going to get big numbers. Why is factoring easy for this one? Why is factoring easy? It is a perfect square trinomial. What's the square root of this guy? 2x. What's the square root of that guy? 7. If I multiply those together and double, do I get that?
Yes.
I do. That is my factoring right there. That is my factoring. So it is very simple factoring. Actually, when I take the square root, I don't even have a positive or negative because it's just a 0. Add 7, divide by 2. Definitely factoring is my easiest. Now, if you did not recognize you had that beautiful perfect square root, right? You definitely don't want to multiply across 2 times 49. You may want to jump straight to quadratic formula, but you would be fine. You would actually have gotten a 0 in your quadratic square root, and you would have had just one answer. But definitely try to find the path of least resistance when you have the option of how to solve. This one, you should have gotten 1 plus or minus the square root of 41 over 10, no matter how you solved that guy. What about number 2? Easiest method on number 2. I would definitely have done taking the root on that one. So number 2, subtract that 1, you get 6. Take the square root of both sides. You can't simplify 6 at all. It's just positive and negative root of 6. That's all you get there. May have some differing opinions on number 3. What about number 3? It's actually pretty simple factoring. 2 is a prime. So you know that you're going to have 2z and some number and z because it's a prime. For 4, you could have used 2 and 2, 4 and 1, but I need to get to 8 and 7. So I need a positive 8 and a negative 7. Your outer make up 1, your inner make up the other. So 8z and 1z gave me that 7z. So then my answer, set them equal to 0, z is going to equal either 1/2 or -4. And again, you may shy away from factoring, so you may have done quadratic formula there, I don't know. But either way, you should have gotten those answers. I agree with this answer. I would have solved by factoring. Here's why. If I get all this over, I subtract that r over. I get that 4r. If I subtract the 7 over, that zeroes out. Then I have just a binomial. All I had to do was take out my r. I'm left with 3r plus 4. Right? So r is going to equal 0 or -4/3. I find that easier than quadratic formula for sure. Right? And remember, to do either, you're going to have to set it equal to 0. All right, so the quadratic formula is kind of a go-to if you can't quickly solve something. If it is factorable, then you already know you're going to have two real answers or two rational answers because you were able to find two numbers that work. So if you are not going to be able to do that and you're trying to figure out, well, what type of solutions am I going to have? There are certain things that can happen inside the root. So the first thing that can happen inside the root is that you could get a perfect square, 25. If inside the root I get 25, I know I'm going to take the square root of 25, which is 5, and then I'm going to add the 5 and divide, and I'm going to subtract the 5 and divide. And I'm going to get two real answers that are rational numbers. By that I mean I don't have a square root left in my answer. And so that's one of the options. You have a perfect square. You are going to have two rational answers. And by rational, I'm talking about our number sets that we learned at the beginning of the year as a review from Algebra 1. Rational means any number that can be written as a fraction. So pretty much I'm excluding my square roots that don't work out, like square root of 21 or something crazy. Sometimes I'm going to get this positive number in here, but it does not have a perfect root. I may be able to simplify the root, but when it's all said and done, my answer is still going to have a root. When that happens, you still have two answers because you have that plus and minus, but it is irrational, meaning I cannot take the number out of the root completely. So if you get something that's not a perfect square, you're going to have two irrational answers. You could also have a real number in there that technically has a perfect root. That is 0. You can get 0 inside the root. If you get 0 inside the root, then you only have one answer. Because whether I add 0 or subtract 0, I get the same thing. So if your root gives you a 0, then you're only going to have one number. It is still going to be a rational number. You don't have a root left in your answer, but you only have one of them. And then the last thing that can happen is you could get, whether it's a perfect root or not a perfect root, you can get a negative number in your radical. When that happens, you also have two answers, but they are imaginary. They are complex. And technically, they're complex conjugates of each other, meaning you have one plus of that and you have one minus of that. And so you have complex numbers if you have a negative inside your root. What that means is your answer is going to have that infamous I in it. And it doesn't matter whether you have something like a 9 that has a perfect root in there, or if you have something like 15 that does not have a perfect root. They will still be complex numbers because you have to take that negative out with an I. And all of that is determined by the determinant. So if all they're asking is, hey, what type of answers are you going to have? You don't have to do the negative b plus or minus the square root of b squared. You don't have to do the whole thing. You really just have to do the b squared minus 4ac. And that will tell you what type of answers you're going to have. So let's look at this. It says use the discriminant to determine the number and nature of the solutions. It's not asking me to actually solve it. It's saying I just want to know what type of answers you're going to have. So make sure it's in standard form. You're going to have to do the same rule as if you were doing the entire quadratic formula. But if they're only asking for the discriminant is just the b squared minus 4ac, just that portion. That's all we have to look for if this is all they're asking. So I'm going to say b squared minus 4 times A times C. All right? And just this alone is going to tell me what I have. So I'm going to do my order of operations just as though I was doing the quadratic formula. That means if I did this entire thing out, I would have a negative 71 inside my root. What type of answer would I have? I would have two complex answers. Two answers, but they would have an I in them. Two complex answers. Let's look at the next one. This is not in standard form, so I need to get it in standard form. All right. And again, I'm just doing the b squared minus 4 times A times C. Zero. I have a 0 inside my root. How many answers and what type? One rational, because the square root of 0 is just 0. And so your discriminant tells you what type of answers you should be looking for or you should have. All right, so for those, I want you to determine the number and the nature of the solutions. You do not have to solve the entire equation. I just want you to use your determinant to tell me what type of answers you have. We've done something similar to this, but now we're talking specifically about quadratics, and they've thrown in this crazy I over there. So they want us to write the quadratic. They have given us the answers. They've given us the answers, and they want us to write the quadratic. If it is a quadratic, I have technically two answers, all right? I technically have two answers, even if they're the same answer, okay? So even if they're the same answer repeated, I technically have two answers. And so if they give me something like this, 2/3 is the only solution. In order for it to be a quadratic, I have to have two of those. So the first thing I'm going to do is say, well, how do I know what my binomial looks like? So you want to get this as a binomial equal to 0. And you do that by multiplying both sides by 3. I'm trying to get this equal to 0, so I have 3x equals 2. And then I'm going to move that 2 over. There's a pattern here that is created. So that is the binomial that had to create that answer. If my answer was 2/3, my original had to look like this. 3x minus 2, add 2, divide by 3. So what happens here is the denominator becomes your coefficient. The numerator is the opposite. So if it's a positive 2, it's going to be a minus 2 here. But it is a quadratic. So if I gave them 3x minus 2, I just gave them a line. How do I know that? Because our bell work reminder, a line is mx plus b. If I were to graph 3x minus 2, I would graph a line, not a parabola, which means I do not have a quadratic. In order to create a quadratic that has only that answer, it means that answer happened twice. So it means that what this quadratic looked like is it had a 3x minus 2 and a 3x minus 2 when it was all said and done, when I factored it, which means technically I got two answers because the one answer repeated twice, all right? Well, they want me to hand them the quadratic. Is this a quadratic yet? No, this is two binomials. How do I turn those two binomials into a quadratic? What's the process to go from here to my final answer of what a quadratic looks like? I FOIL it, right? And so that's what I'm going to do. I'm going to take this and I'm going to FOIL it. And we should know how to do that. So 3x times 3x, 3x times negative 2 times 3x and negative 2 times negative 2. Simplify it. This quadratic will give me 2/3 as an answer. If I were to factor it, I would get 3x minus 2, 3x minus 2. If I were to solve, I would get 2/3. All right, and so now we're working the other direction. They've handed it to me. They want me to come up with the answer. That's not so bad. Let's look at the next one. The next one looks a lot more complicated. It's not. So for something like this, whether I have an I or whether I just have this crazy radical, what I really want to do is get that radical and its coefficient, we can leave the coefficient there, by itself. So I'm going to do that by moving the number that's all by itself over. Subtract that 5 over x minus 5. That leaves me with this positive or negative 2i square root of 7. All right? How do I get rid of a radical if I'm solving something? How can I get rid of a square root in an equation? What can I do to it? I can square it. So I am going to square both sides here. All right? I'm going to square both sides. This I'm going to end up foiling, right? So this, when I square it, should look like that. That's not hard. Let's look at this crazy guy over to the right. If I square positive 2, what do I get? 4. If I square negative 2, what do I get? 4. So if I square this positive or negative 2, it doesn't matter whether it's positive or negative. I am always going to get a 4. What happens when I square an I? I squared. What is that? Negative 1. What happens when I square the square root of 7? I just get 7. So as hideous as that looked, squaring it actually makes it rather simple. I just square each piece of it. Do you see that? So then I'm going to finish this out. What am I going to do on this left side? We just did it. What's that process called? Foiling. We get x squared minus 5x minus 5x plus 25. On this is all multiplication. What's 4 times negative 1 times 7? Negative 28. All right, I want this to be a simplified simplified quadratic, x squared. Combine your like terms. Add that over. Add it over. And I have what gave me that crazy answer. All right, so even though it looks awful at the beginning, and even though those answers don't look pretty, they actually work out to a regular old trinomial because that's what we've been doing the whole time.